Good morning, everybody. Welcome to this first session today. The title is On Ruby and Ruby, or How Scary Are Trojan Source Attacks. This is the overview. I'll have you scared at some point a little bit. So if you don't like to get scared, maybe, leave. This is my introduction, just to show that I have done related stuff before. Me and my students have also contributed to Ruby in many different ways, mostly on internationalization. Okay, the start for this talk is this paper, Trojan Source Invisible Vulnerabilities. By the way, there's a spelling mistake here. This word is very interesting in terms of English orthography, in that the spelling of this J here is actually changed for the adjective. It should be a J. Anyway, so this paper came out about 2.5 years ago, and it was revised. It will be presented later this year. No, 1.5 years ago. And we look at this. Who wrote this paper? Well, Nicholas Boucher is probably a student in Cambridge. Ross Anderson is a well-known security expert. And there's some, where is this information? Where did it go? Well, I had it on the slide. I'm not sure where it went. This book is actually 1,200 and something pages and 1.8 kilograms. If it was a little bit lighter, I would have taken it here and shown you, but it's kind of too heavy. Anyway, so really a heavyweight in the field of security. Okay, now let's look at this. Imagine that you're out on the sea at night, and there's some fog and so, and suddenly you get attacked, yeah? So I'm not sure by zombies. I gave a lightning talk on zombies once at the RubyKaigi, whatever. So that's actually the website of this paper. So I would at least give this paper a prize for scariest website that goes with the paper. Anyway, so let's go back to the talks. And let's see how good you are with Ruby. This is a small Ruby program. And the question here is, who wins? Or not exactly, I mean, white should win, but what will the program print out? So can I please ask your hands if you think after executing this program, it prints out white wins. Please raise your left hand. If you think it will print out black wins, then please raise your right hand. And please, everybody, give it a try. Everybody give it a try. Okay, we have a lot of left hands. We have some right hands, just contrarians for whatever reason. Okay. Let's go to the next example. This example looks exactly the same, but it's actually different. It's actually different. I can show you here. It will all these variables. No, actually not. Why not? No, it should. Sorry, it should. Now I'm slightly confused. It should have shown that here. Anyway, so again, sorry for the confusion. For this program, who thinks that white wins? Please raise your left hand. Who thinks that black wins? Please raise your right hand. Okay, we have almost the same result. Okay, let's go on. I have 2 more examples. Example number 3. This is a bit simpler. This is a bit simpler. We don't even do any calculations of the komi. This komi is actually to compensate for the fact that black plays first. That's worth about 6.5 points. Here we don't do that. What do you think? Who wins? Again, please raise your hands. Who think that the program prints out white wins? Who thinks it's black wins? Oh, but yeah, what about you? You should know Ruby, yeah? Anyway, okay. You're not too wrong. You're not too wrong. Okay, let's go to the next program. Now, now it gets really interesting. Well, it was interesting before, but you just didn't see it. What will this program? This is a legal Ruby program. This is a legal Ruby program in most of the versions that you have, I think, installed. Yeah. So now, again, questions. What will this do, this program? If you don't know, just take a guess. So please raise your hands. We have this. This is not too bad, yeah? Okay, so we are done with the examples. Let's see. Here are my guesses of your guesses, and this was a little bit of a bet, but I think I wasn't too bad. But I mean, I decided to have this outcome. Okay, now we have to go to this thing here, and you have to, just for a moment, you have to believe me. You will be able to download the code later. Let's run this program. Okay, so some people suspected something, and just as contrarians, they said, no, it won't be what it looks like. So yes, indeed. Okay, so now we have to actually explain this, yeah? The real result is black wins 4 times. I have to apologize. It's not your fault that you guessed wrong. It's my fault. So don't think don't lose your confidence in your Ruby knowledge. Okay, so let's look at where the problem is. In example 1, there are actually just some special characters here. So the assignment goes to a different variable, and so white and black are at 40 and 45, and then the score is negative, and black wins. Okay, to get you a bit more details, one of the I's is actually the Cyrillic small letter Belarusian Ukrainian I. In Russian, they use a different I. You see, we even have some political implications here. It's interesting to note that the Belarusians and the Russians are together. No, the Belarusians and the Ukrainians are together, whereas the Russians are separate. In politics, it's maybe a little bit different. But that's maybe a reason why the Belarusians don't want to help the Russians too much. Anyway, this one is called a homoglyph attack. And what are these? Well, they use identifiers that look the same but contain different characters. And this is well known from internationalized domain names. Not in the sense that it happens there very often, but in the sense that people have thought about that a lot for internationalized domain names and done a lot that it doesn't happen too often. It's an old problem. There was the so-called PayPal scare in 2005. And there's lots of data and advice available. Here, I'm just giving you the links. So next, what's going on in example 2? I actually wanted, it didn't work out the way I designed, but I wanted to show you that in example 1, we cannot search for the word white throughout the text, but in example 2, we can do that. But there is an invisible zero-width space, yeah? Because it's zero-width, you don't see it, yeah? And why is this possible? Well, it's possible because Ruby allows all non-ASCII spaces in identifiers. So I'll call this an invisible space attack. And these are not well known, they're not widely possible, and Ruby is an exception, maybe the only exception, I don't know, I couldn't say that. There could be other programming languages that do the same, but we should close this loophole. Okay, next, what's going on in example 4? Well, example 4 is an extension of example 3. There are many different spaces in Unicode. We have used the zero-width space, and I also have used the ideographic space, better known as full-width space. And so we can write a program just with spaces, yeah? Because you can use one space, but you can also use 5 spaces and mix and match them, and then you can write programs with all kinds of invisible variables, yeah? You still have to write if and else and minus and greater than and so on. Unfortunately, we cannot hide that. Well, this is not really an attack. I mean, a program that looks like this is probably going to be discovered extremely quickly. Next example. Here is the actual code, and I'll actually, for the rest of the talk, I'll mostly concentrate on this example 3 because it's quite a bit more intricate. So in this example, I added quite a few more characters, and we'll look at these in detail. What are these characters? They are so-called Unicode bidirectional formatting characters, also called bidirectional control characters. They are also allowed as part of variable names in Ruby. Almost everything is allowed as part of variable names in Ruby. Okay, what's the core here? Well, the core is this subtraction. It does black minus white, but then these special characters, they control the display and reorder the display so that it looks like it's doing white minus black. And that's why most of you got, okay, white minus black, so white should win. And this is a bidirectional reordering attack or binary reordering attack. What characters are involved here? The character RLO, the right to left override, in general forces everything to display it from right to left. Every single character goes from right to left. Yeah? That wouldn't exactly work for us, because then all the words would also be reordered. Here it's just used to change the token order. Then the LRE, this is left to right embedding, in general keeps things left to right where there's a choice. Let's say you have this example again with white minus black. Well, white wants to go this way, black wants to go this way. So the minus in the middle also goes this way, and the whole thing goes this way. If you have Arabic or Hebrew, they go this way, and then the whole sentence also goes this way. But here you can control the overall flow. And in this example, we use it to protect the variable names from the outside influence of this strong override. Okay. And then the PDF is used to, this is not the PDF file format, this is a POP directional formatting, and this is used to end LRE or RLO and so on. It's used here to end the LRE, the LRO ends at the end of the line. Okay, what are these? I already said they're bidirectional formatting characters. They're invisible, but they can change the order. And they are needed for special situations with bidirectional text. They work inside paragraphs, including eFlow. So if you have a page in Word or Google Docs and you make it a little bit wider or narrower, then everything will eFlow nicely. And if you have these controls at the right places, and you can read, let's say, Arabic or Hebrew and so on, then things will just work out fine. Yeah? For programming languages, each line is a separate paragraph in this sense of this algorithm. Yeah? So if we want to have an attack, we have to make sure it works in a single line. Okay, more background. Well, most text is displayed left to right. Not only Latin and kanji and so on, but also most numerals or digits, including the real Arabic digits. Yeah, they go just from left to right. Yeah, but then the text can also be displayed right to left, Arabic and Hebrew. Or some other examples like the text on the right side of Japanese cars. This would read Matsumoto. Oh, there's a character missing there. Unso Kabushiki Gaisha. It should read. Yeah, okay. So, and this can mostly be done just by typing the text in, and then the Unicode BiDi algorithm will just do the display, but in some more complicated situations, additional control is needed, and that's where we need the controls. But what's important is that the algorithm is designed for general text, like books, like newspapers, like reports, and so on. It's not suited for source code. Why is that? In general text, the actual words say which direction they want to go, and things like plus and minus and comma and all these, they just follow the flow. Whereas in source code, the plus and minus and the parentheses and that define the structure, and the words, they just have to follow or should follow the structure. Okay, here's a list of all these BiDi formatting characters, just for your reference. A little bit a closer look at example 3. Why did I use these characters the way I did? Well, the LRO reorders this black minus white so that it reads white minus black. It essentially reorders 5 different pieces. The 3 characters here, and then 2 units of these variable names. Why do we need to put these 2 characters here around the variable names? Without that, we would actually get something like black minus white. Maybe you can read that, maybe not. People are not used to read things the wrong way, yeah? So we don't, that would be too confusing, yeah? Why did I use 40 with a rightward assignment, and not just a simple assignment like black is assigned 40? Well, this would actually display as this, and this doesn't look like Ruby. It isn't Ruby, yeah? Okay. So these binary ordering attacks, we can, there are different kinds. One is an identifier attack. That's what I showed. That's maybe only in Ruby, and we definitely need to eliminate this. Then there are comment attacks. This works mainly for comments with closing delimiters, because you want to you can do something at the end of the line. You can put a special character inside the comment where it doesn't get checked there in the comment. You can write anything. And then that makes sure that something that actually is after the comment is then exchanged and shows up as if it were inside the comment. Yeah? And that's what they do in the paper. And then also string attacks. It's the same. After a string constant, you have something, and inside the string you have some special control that moves the something that gets executed inside the string so that it looks like it doesn't get executed. And that's also possible in Ruby. It's possible virtually everywhere. Okay, these are just the pointers to the vulnerabilities. For both of these vulnerabilities, it says disputed. Well, because the vulnerability said, there's a security hole in Unicode. Yeah? But actually, that's not really correct. We would have to say that there is a security hole in human writing culture. And we cannot just change that. Or hopefully we won't change that. Okay, so when this came out, there was a little bit of finger pointing. Some people said, well, it's Unicode's fault. Some others said the language specifications should be fixed. Some said the language implementations should be fixed. Some said, well, but the editors, the IDEs could do something. And then somebody else said, well, but yeah, but why not leave that to linters or something? Yeah. So, but it's not really any single party's fault, and finger pointing doesn't solve any problems. Also, some people said, well, why not simply disallow any non-ASCII characters in code, or even in comments and so on? And that just doesn't really fly, because these are useful for education. They are useful for bureaucratic jargon also. It can be very difficult to translate that. Just in general, if you look at the map, for example, outside, you might maybe realize that in areas where they use, except Japan, in areas where they use lots of scripts outside ASCII, there's lots of white space. So we definitely should keep that. Okay. So I hope I have scared you quite a bit, but here are some arguments why not to completely lose your sleep, yeah? Especially not over Trojan source attacks. Maybe there's other things to worry also. In general, things like phishing scams are much easier than Trojan source attacks, yeah? Because programmers are more careful than everyday people. I mean, especially if you can send out spam emails to hundreds and thousands and so on, and you get some money from one person, you also already have a win. Yeah, I mean, it's already a win for the bad guys. Homoglyph attacks are possible with ASCII too. There is this famous case of this guy who was fishing for manuscripts with a domain name of Random House. Random House is a famous publishing house. And so that means that people don't look too closely anyway. Most people, if they click on a link, they don't actually check the address, even if the address is explicitly written. Even if we could solve this Trojan, this homoglyph problem, we would still have quite some issues. And the other thing is also that in Ruby, any method can be overwritten from anywhere in the code because all these classes are open and so on. And so you don't need to do homoglyph attacks. You can just use the same name and put that method definition in a corner somewhere where people don't notice. Anyway, so what we need is defense in depth. We need maybe something, language specification. I mean, in our case, the language, one of the language implementations is the specification. And this goes as far as a healthy ecosystem. I'm sure you cannot avoid, if somebody really wants to infiltrate our ecosystem, it might be for a really trained spy, it might be possible. But at least if somebody shows up and says that he or she worked for the NSA and the CIA or maybe whatever other organization, maybe we should be a little bit careful. Yeah. Okay, then what do editors do? Well, I just want to show you some examples here. This is how Notepad 2 displays things. You don't see anything special. Yeah, you don't see anything special. But then this is, for example, how Visual Studio Code does it. They changed it after this paper came out. And now you can see here very clearly, maybe make this a bit bigger, you can see it very clearly that there's something special going on, maybe too clearly. And you can also see the white box here, the yellow box here and here. And this shows you that something might be, something strange might be going on. Okay, so for editors, it's all over the place. Maybe the advice is just for your company or organization, don't force everybody to use exactly the same editor. Yeah? Some variation plays out. There's also discussion in the Unicode Consortium about the ideal editor that should understand the programming language. This is mostly for displaying programs with actual Arabic or Hebrew or whatever text in it, which I didn't show too much this time. With syntax highlighting, we have a lot of information for doing things correctly, but on the other hand, it's almost impossible for embedded code. If you have BiDi text in a regular expression, in a string eval, in a here document, in an ERB document, then you probably won't have an editor that understands all these levels, and maybe the string eval might be in JavaScript, and the regex might be this and this variant, and so on. So this is kind of impossible. Yeah? But what the editor should do is order programming language tokens left to right, and then for each token, if it's, for example, an Arabic variable name, it should, of course, display it as Arabic so that you can actually read it if you can read Arabic. OK, how much time? I don't have much time anymore. Well, the next steps for Ruby should be done. I actually worked on an implementation over the last few weeks, but I somehow got hung up with it. I suddenly had too many errors to be able to commit it, so I'll go back there and fix that, so that we can eliminate non-ASCII spaces and formatting controls and things like non-assigned characters and so from variable names. And we also should do something about mixed script variable names, but there we actually have all the data, but the data is in the wrong form. OK, so as a summary, these are my representations. Use this fence in depth. So don't just blame it on one single part of the ecosystem, but make sure you watch out. And of course, we should fix things for Ruby, and I hope we will do it soon. Then there are acknowledgements. The acknowledgement here is somehow a little bit, well, they're maybe a little bit too scary. They scare people too much. OK, thank you for your attention. And for questions, you can send them to this address, or you can also, of course, contact me directly, and I'll make sure that there's a link to the presentation from the description of the talk. OK, thank you for your attention.